lesson is broken up into two parts, so we're just going to focus on the kites for today and the trapezoids for tomorrow. So 5-6A is kites. For the vocab here, a kite, you can tell how in this kite opposite sides aren't equal, right? It's kind of oblong. So that makes it not a parallelogram. Look on your chart. See how there's no line connecting the parallelogram to the kite? Can you see that? You focus over here, please. I don't have a kite up here, or a chart up here, so I can't show you, but there's no line connecting the kite to the parallelogram. They don't go together. A quadrilateral for a kite is one that has exactly two pairs of consecutive congruent sides. A parallelogram has opposite sides congruent. A kite has consecutive sides congruent. Consecutive means side by side, next to each other. Okay? So instead of opposite sides being congruent, you would have these two sides right next to each other being congruent. And you would have these other two sides over here right next to each other being congruent. Now that makes a lot of things congruent to each other. Certain angles are congruent, certain angles are cut in half, and we'll go over all that after we go over the properties. Alright, so let's look at specific rules to a kite. If you have a kite, if a quadrilateral is a kite, then the diagonals are perpendicular. That is similar to a rhombus, but it's not in the rhombus family. It's its own rule for kites. Every time you go in the middle of a kite where the diagonals meet, you have a right angle. 4 right angles right there. Which gives you 4 right triangles. Which gives you lots of congruent triangles. Do you think that this angle is equal to this angle? Yes, because these two triangles are congruent, which means all of these corresponding parts are congruent. Is this angle equal to this angle? Okay, you're going to say yes because those are the ones I'm pointing out. But look for the ones that are congruent there. All the corresponding parts are congruent. Another rule, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. It's this angle right here is congruent to this angle right here. And it's because you have congruent triangles. I'll go check it in a second. Alright, so when this angle is equal to this angle, notice that it's the angles that are in between the two non-congruent sides. This angle is not equal to this angle. Okay, so this angle is not equal to this angle, only these two are. Does anyone see a binder over there that was left behind?
Yeah, thank you.
Okay, so look at this. I don't know if this is, oh, I did put it on yours, okay. So look at this right here. What other properties do you see? Draw this line right here. What can you say about this middle line right here? Making congruent triangles, because what would you call about this middle line right there? Reflexive, good. And reflexive gives you congruent triangles by side, side, side. So once you have that, you have a whole bunch of congruent parts, right? This angle is equal to this angle. What happens right here? If these two triangles are congruent, what's true about these two angles? They're congruent as well. So look, one diagonal does bisect the angles, but it's different than a rhombus because it's not both diagonals that do it. Only one diagonal, the longest diagonal that goes, I'm sorry, it's not always the longest, but the one that goes in between the matching sides, this side, and this matching side, that diagonal cuts everything in half, the two congruent triangles. Okay, and that's going to be important for finding the missing parts that you need. Any questions on that? Okay, fill it into your chart, please. The thing about a kite is that there's so much information there that we can't possibly fit it all in. We can't possibly write a rule for everything because when you get congruent triangles, then you get so many corresponding parts congruent. So we're just going to write the basic rules about diagonals, but everything else you can still figure out as you go based upon the fact that you have congruent triangles in there. So kite, definition. What makes a kite a kite? Good. Congruent consecutive sides. Both times it has to be true. Meaning the sides next to each other. These two are equal and these two are equal, not across from each other. If opposite sides are congruent, it's automatically a parallelogram. This is not a parallelogram. Alright, what was the rule about diagonals? What happens when the diagonals meet? They don't bisect each other because that's only in the parallelogram family down the left-hand side of your chart. On the right-hand side, we're dealing with other things. What does it say about diagonals? They're perpendicular to each other. Good. This one right here. Diagonals are perpendicular. Everywhere you look in a kite, when you look in the middle where the diagonals meet, you have a right angle, which gives you right triangles. And you can subtract from 180, and you can do all the stuff that you do with triangles. And then one of the diagonals bisects the angles. Be careful though, because it's only, this one is one pair of opposite angles are congruent. Write that one down. And we can also say one diagonal does bisect opposite angles. And it's all about splitting the kite down the middle, and you can see where all the congruent parts are. Alright, so keep your chart out there. Let's look at some true falses. Let's see what we've got. And then we'll deal with the missing problems the missing angles down on the bottom. Anyone still ready? There's too many rules to write here. There's just so many congruent triangles and everything that happens in a kite. Let's try this one. All kites are quadrilaterals. Quadrilaterals, four sides. True or false? True. They're all in the quadrilateral family. Says to justify your response, so I just wrote a short thing there. They have four sides, just like all quadrilaterals. Begin number 2. A kite is a parallelogram. Good, that's false. The reason is because opposite sides are not congruent. Opposite sides are not even parallel. Okay, only consecutive sides are congruent. A kite can have congruent diagonals. True or false? False. Good. Because in a kite is always oblong, and one will always be longer than the other. If the diagonals were congruent, it would be a square or a rectangle. Okay? So in a kite, no, one is always longer. Less. Both diagonals of a kite bisect the angles. Both of them bisect the angles. Look back here. Do both of them bisect? Does this one cut that angle in half? The one that I'm pointing to up and down? No. Only one of them can because of the congruent triangle, side angle, side. So no, this angle does not get bisected. Only one of them can do that. So only one does. Both diagonals bisect. That's true for rhombuses. For a kite, it's only true for one of the diagonals. And that makes kites a little bit tricky, but if you don't think of it as all the properties of a kite, if you think of it as two triangles split right down the middle, it'll be easier for you to find the congruent parts. So let's do that with the bottom there. Okay, angle 1. Let's find angle 1 first. This is a kite. Angle 1 is right where the diagonals meet. What kind of angle is right there? A right angle. Yep. Kites had diagonals that are perpendicular, so angle 1 is 90 degrees. Alright, angle 2 is not easy to find next. Let's find angle 3 next. Angle 3 comes from this triangle right here. again. Find this one. How would I find angle 3? You need a clue there that I haven't written in for you yet. There's a 90-degree angle right here. Good, excellent. And there's a 55-degree angle here. How are you going to figure out angle 3? Subtract from 180. You got your calculators? Can you help me with that?
35.
I think it's 35. Tell me if I'm right or wrong. Subtract 55 and 90 from 180.
Yeah.
35? Okay, so we'll put 35 right here. Now what do you think angle 2 is going to be? The same thing because of this right here. See how this angle? This is the one that gets bisected. You go right in between the two sides that match. See how this side matches this side? And this side matches this side? That's how you know which diagonal is the one that's cutting in half. So this one is the one that's cutting everything in half. So you have 55 and 55, and then you have 35 and 35. Okay, 35 and 35. Next easiest one to find is angle 5. What would angle 5 be? 62. Yep. It's not the same as this one across from it. Okay? These are the ones that get cut in half. And the only way to memorize that is to memorize that it's the ones between the two matching sides. Those are the ones that are equal to each other. And then the last one to figure out is angle 4. It's not 35 because this one is not the one that's getting bisected. How would I find angle 4? Do you see this right here? What is this? 180. And what is this? 90. So do 180 minus 90 and minus 62, and that's how you find the missing angle. 28. Okay, so I want you to notice something. These two angles are not the same. Do you know how you know? Look, because the sides around them are not the same. Can you see that connection? Since these two sides don't match, then the two angles inside don't match. Since these two sides right here match, can you see the matching two lines? That's how you know that these two angles inside here do match, okay? And it's not something to always, it's easy to see, but it's easy to forget as well. So try to memorize that. Where the sides match, in between there, that's where your angles will match. All right, so turn the page, let's try some. See how many there are. All right, so I'll go down the left-hand side, and then I want you to try the right-hand side while I do your homework. So, we need to figure out angle 1 and angle 2. First of all, I'm going to point to two angles, and you're going to tell me if they match or don't match. The way you know is by looking at the sides around them. Will these two right here match?
Yeah.
Yes, the sides around them do. Will these two angles match? No, because the sides around them don't match. But do you see it now? Will these two match? Yes, because the two sides around them match. So we need to figure out angle 1. So I would start by looking at this triangle right here. You know one angle is 18 degrees. You know the other angle too. What's this angle right here? 90. So figure out what angle 1 is. 90 and 18 taken away from 180. Check me with your calculators, is this right? Okay, I saw someone nodding. I'm hoping that I'm right. I did it in my head. Is that right? 72? Okay, so now, the other rule is that opposite sides or opposite angles are equal when it's in between those two non-matching sides. But what you have right here is an isosceles triangle. Yes, Leslie, sorry. So if you have an isosceles triangle right here with these two sides matching, then these two angles have to match. So this one's going to be 72 as well. There is just so many triangles, isosceles triangles, congruent triangles. There's so much of everything inside the kites. Number 2. Measure angle 1, measure angle 2. Angle 1 is very easy. Angle 2 is going to take a little bit of work. Look at angle 1. What would that be? That's right. Because remember, don't draw this. I'm going to erase it in a second, but I just want to remind you that when you cut it down the middle, you have congruent triangles. So this angle equals this angle, 110 degrees. Okay, so the angles in between where the two sides meet, those two are equal to each other. Not always the obtuse ones. All right, so how to figure out angle 2? You could do that, cut 98 in half, and then subtract from 180. That's true. What if I wanted to just use the whole thing? Look at your chart. How many degrees are there in a quadrilateral? 360, right? So you could save yourself a little time as well and do 360 minus 110, 110, and 98. And then if you cut 98 in half, you did it that way, you found one angle, you'd remember to multiply by 2 again, right? Good. So 360 minus 110 and 110 and 98. What does that come to? You can answer? No, it's 360 minus. See, some of you have calculators on your desk. Did anybody subtract it? Huh? 360 minus 110 and 110 and 98. 42? Okay, so the triangle rule is true. If you break it up into triangles, you could do that. For a quadrilateral, it goes up to 360. Are you going to try the next two? I'm going to give you about 5 minutes. Try it while I stand for you.